Introduction to programming. What is a program then? A computer has a CPU, a central processing unit. The central processing unit is the heart of the computer. It's the electronic chip that does the processing, that does the arithmetic operations. A computer only knows to do arithmetic operations, basically. Another important piece of hardware component in the computer is RAM, the random access memory. We should also say that the CPU has registers inside, and we will explain what these registers are used for. And we should say here that the computer is doing basically arithmetic operations, addition, subtractions, etc. What is a program? If we want to give orders to the central processing unit, we write a program. Otherwise the CPU, the computer, is not going to do anything. It will be just waiting for us to give some orders. The orders are given in the form of a program. So we need to prepare our data in memory, in a random access memory. We need to tell the central processing unit to carry out operations on the data. And this is the program. The program has data and instructions on how to manipulate these data. Random access memory. I think you might be familiar with this picture of the random access memory. The random access memory holds our data. Each memory position has an address, and each memory position has a content. Do you see on the right? This is a table with memory addresses from 0 to 1023. It is a 1 kilobyte RAM, random access memory. It starts from 0 to 1023, and each memory slot has a number which is called its address. On the right you see that each memory slot has a content. That's the memory. Pure data stored in a big table. Now let's talk about a little bit about the numbering systems. You saw in the previous slide that we are using here zeros and ones in the binary numbering system. We also see here the corresponding representation in the decimal numbering system. So decimal is the most popular numbering system in our human world. It is very easy for the humans to use. It has been invented from the start because decimal has 10 digits, which equals the number of fingers we have on our hands. Computers basically use the binary numbering system, which is composed of 2 digits, 0 and 1. Other popular numbering systems in the digital world are the octal, which is composed of the digits 0, 1 up to 7, and the hexadecimal numbering system, which is composed of 16 digits starting from 0 up to 9, A, B, C, D, E, F. Now, assembly. Assembly is a language that can be used to write a computer program. It's quite difficult to write a program in the assembly language. You need to know the architecture of the central processing unit, what registers does it have, and you need to give instructions directly into the registers, and you need to know the register, the instruction set of the CPU. you can see here a program which does a very simple thing, gets a number and stores it in register AX, and if this number is in the range 97 to 122, it subtracts 32, otherwise leaves this number unchanged. When we write assembly language, we usually accompany each line with an English statement that works as a comment, as an explanation of what the line does. As you can see, this is a procedure which has quite cryptic, let's say commands, but and it does very simple thing, and it's difficult for the programmers for everybody to write the program. This is the way it used to be quite back at the beginning of software engineering. One wanted to write a program, a computer program. Today we are using high-level programming languages. On this slide I show the same procedure written in Ruby. It is very simple and very descriptive. You only need to read the code to understand what it does. There is no need to write any extra comments. So this procedure returns, which means it ends, it does nothing if number is given is less than 97 or number greater than 122. Otherwise it returns the number minus 32. It's exactly the same functionality, but you can see in the high-level programming language we don't need to know about the registers, we don't need to know the instruction set of the central processing unit. I will finish this presentation giving a comparison between two big families of languages, the static languages and the dynamic languages. Examples of static languages are C, C++, and Java. Here you can see the same. Program like we saw before, written in Java, is a little bit more verbose than the one we have written in Ruby in the previous slide. With static languages, the source code needs to go through a compilation phase, which generates the binary executable file, the .exe in Windows. You need to be more verbose and specific. For example, when you declare a variable, you need to give its type. Generated programs usually run faster than programs with dynamic languages. However, they are quite restrictive, and sometimes in order to do simple things you need to write a lot of code. Of course, they are very popular. They generate, as I said, very fast code because it is native operating system code, and of course they have their purpose to be there. Dynamic languages. They are also called script languages. Examples of them are PHP, Ruby, Python, JavaScript. They are using another executable that will take the source code and execute it line by line. This is usually called the interpreter. They do not need a compilation phase. The source code is the actual program deliverable. They are open source. Everybody can see, read the source code and understand what the program does or what the program should be doing. So I hope that I gave you the first idea of what a computer program is. We will definitely go into programming and the real hands-on experience in the next sections. Thank you.